Hello, everybody. Welcome to SwivelSec or Southwest Florida Security Group. This is May 22nd, 2025. And we have a speaker for today's meeting. So we're just going to do some slides real quick to kind of tee it up, and then we'll get right into the talk. So if you haven't joined before, we are, yeah, like I said, SwivelSec. Maybe not in the future, DEF CON Group 239, but that's what we're registered at now. So we serve Southwest Florida. So that's, um, Collier County, Lee County, the surrounding areas there. We try to meet once a month, either in person or hybrid. Anybody can come. We're not really, particulars about if you're in information security or not. We actually have a imposter syndrome disclaimer on our website as well. So, all experience types we welcome. We try to make it as vendor neutral and kind of free and open as possible as well. So it's just really to getting together and promoting cybersecurity. That's our purpose. We're also part of a broader group called the Tech Alliance of Southwest Florida. So what that is a group of groups essentially with their kind of own leaders and kind of own agendas throughout the community. That's a nonprofit and nonpartisan as well. So we meet as a whole group, so all of the subgroups and as one, at least once a year. So we have an in-person meeting. We had one in January, kind of like a New Year networking group kind of thing. It's good. We had snacks. We had some speakers. It was a pretty nice time. So every now and then we'll kind of have a larger group. But right now we've got SwivelSec, we've got VRAR of Southwest Florida. So if you're interested in virtual reality, augmented reality, anything kind of in that vein and coding with that. We have that group. There's Southwest Florida coders, so anything to do with coding, writing code, scripting and all that. Um, Python Southwest Florida, so that's part of our group. Music Makers of Southwest Florida and the Hackerspace. So Music Makers is just producing music, digital music, understanding the tech involved in that. And then the Hackerspace is trying to get an actual space to do hacking. But when we can, we've had some meetings, about soldering and easy waste recycling and 3D printing and things like that. So um, there's that group as well. And then we all come together to under one Discord server. So I'll show those here in a second. Yeah, next slide. Cool. So we've got one for SwivelSec itself. So if you're on Discord, you can join that one. And there's also one for the Tech Alliance. We also have a lot of socials. We've got all the QR codes here. There's links to everything on our website. It's just swflsec.com. Pretty easy to remember as well. And I put the links in the chat, and I don't remember if they show up for people who would join after there, but I'll put them in there again. So you can just click on those as well. So have that. Oh, and we do have a code of contact as well for the group. Pretty basic stuff. We also operate all of our meetings under the Chatham Health Rule, which is basically something that this group of people came up with. And it's about creating a trusted environment so that you can actually kind of work through problems and, be able to kind of share some information and learn from it, but not kind of reveal, details and sensitivity, which happens a lot in cybersecurity, right? So you can share kind of what you learn, but not really the details about who said it or what it might be a part of. So whenever you have a meeting, you kind of go under that rule. So, an example is, I heard at a cyber club meeting that it's good to have strong passwords, more than 4 characters. That's an okay thing to say. What you wouldn't say is, Megan said that, her work got compromised because the passwords were too short and it was only 4 characters, right? That's too intimate and, potentially creates problems. Again, in cybersecurity, especially when information gets shared, it can lead to, a lot of hacking and a lot of other interesting things, which is what we're talking about tonight. So, um, but yeah, basically that's the gist of that rule. And then, yeah, so yeah, I just want to get right to our speaker. So we have Julian Reynolds tonight, who's going to talk about AppSec risk and the initial access getting into those applications. So,
Sweet.
so we're gonna swap decks here.
Thank you, Megan. Okay, let's do this. Perfect. Okay, we'll jump right into it then. This started out as a little bit of AppSec, and then it kind of expanded into a little bit of just general initial access for red team pieces. And really, this is kind of a casual conversation. I really wanted to give an example for people that may have kind of read about a lot of this stuff, but may have not seen actual exploits in the wild and what's actually out there. So all of the things I'm going to show are real examples that were found in engagements that were done either by myself or people on my team. So for who I am the manager for Trace 3 Offensive Security Team. Before that, I worked at Taco Bell Security. I do penetration testing as well occasionally, not as much as I used to. Video game nerd, electronics tinker, CTFs, hack the box, all those fun things, right? So still keep involved, right? We're going to go through kind of general purpose red team stuff, some real world examples, some why are those still missed, and then some tools and recommendations for kind of attacking those in the AppSec space, right? When we talk about red teams, really commonly the perception is post exploitation, and it's very important. Post exploitation is a big part of red team. A lot of times when you're doing red team engagements, it's about trying to avoid detections, move through the environment, things like that. So you're spending a lot of time in that post exploitation phase. However, it is still important to look at the initial access piece. I mean, that is still one of the primary attack methods for things like ransomware and stuff is getting that initial access. A lot of days, or a lot of times now, it's, credential abuse, social engineering, breach credentials. We're going to talk about all that. There is still examples of, web apps, SaaS, and third party and actual technical exploits like that can lead into these engagements, lead into kind of compromise for these companies, right? When you look at this is the MITRE ATT&CK framework. If you look at kind of what's involved in AppSec and applications and those sort of pieces, obviously a lot of it is on that initial access, that reconnaissance, for example, but it kind of spreads out throughout the rest of the piece. All the little blue boxes are ones that relate to that. So you've got things like cloud storage and content injection and C2 channels and access tokens, right? These things exist primarily on the initial access or the external perimeter, but they affect throughout the whole kill chain, right? There's steps and pieces that can be used throughout it. When we start looking at kind of real world examples, I'm not going to dive too much into this because it's kind of its own topic, but breach credentials, credential stuffing, these are still some of the primary methods, right? Credential stuffing remains a big, big piece. If you've ever used Have I Been Pwned, for example, things like that, there are lots of credential lists. So it's very important to be aware of that. If you're building applications, any sort of authentication function should be considered to kind of address this, right? And there's a couple of different ways. Really, the best way, and depends on the application itself, is in MFA, right? Even low privilege applications or simple ones should have an MFA option, maybe not necessarily a requirement. It should be required for any high privilege or employee ones. It's the single biggest thing you can change that will have the kind of the largest impact. Besides from that, you start to get into the cat and mouse game of rate limiting and lockouts and threat intelligence and all those fun things. There's lots of services around those that will help. And there are improvements to be done, right? At the end of the day, a lot of times when you're addressing credential stuffing, it becomes a question of how many blockers can you put in the path of an attacker before they either go somewhere else or their scripts fail and they just mark it down as failed, right? If you can do that, a lot of times you can prevent basics. Breach credentials, credential stuffing does work. It is still, a common thing. 2023, Verizon data breach, 83% of the breaches, external actors, almost 15% of them use stolen credentials. These examples here, this is from a red team that was done from our team using a partnership with a company we have called Flare.io. They provided some breach credentials that were just found on the dark web that gives access to this porting interface, which was an ISP interface that allows for viewing of personal information and even doing things like changing phone numbers and those pieces, right? That was just breach credentials, identified, logged in, right? So that sort of access does still exists, and it is very important. Bigger ones like that is the the AT&T Snowflake breach. This is stolen credentials again. The accounts not configured with MFA, credentials obtained via malware. This ties into kind of third-party pieces. We're going to talk about that a little bit as well. Understanding the supply chain, understanding what exists in your applications, both from a technical perspective and in this case, kind of a company perspective, are important. So that's kind of the boring stuff. When you're talking about initial access, it's important to talk about these. They are the real world kind of most common ones. They're not necessarily the most enjoyable, right? They're kind of, yeah. Going into kind of the next pieces here is phishing. Phishing is still a pretty common one. It has gotten more complex and different, and we're going to talk about a couple of different attack paths. This is a phishing campaign that we did. Built out a great job, kudos sort of piece, submitted it against a real target, and might be a little small here, but the little red box there is submitted data, right? So that's a person that actually clicked into this, clicked into a simulated login page, put in credentials. Using those credentials, we're able to gain access to a user account on the internal AD. That user actually had permissions to do a DC sync attack, right? So just by getting those credentials, we're able to escalate all the way up into what is effectively domain admin, right? So credentials still remain one of the key initial access pieces, and obtaining them, whether that's through technical exploits or in this case, social exploits, is still kind of the primary piece, right? So with all that kind of out of the way, we're going to talk a little bit more about some more interesting ones and then dive into that, right? Phishing has kind of been evolving quite a bit. This is usage of Evil Engine X or Evil Engine X. I don't know how to say it. But basically, this is kind of an evolution of phishing where you are doing a proxy. So instead of, the one we showed you before, the one I showed you before, is more of like, hey, click this, it takes you to a site, it just captures your data, and then it says, oh, there's an error. This way, it does a proxy to Microsoft, and when you log in, it actually logs in successfully. It just happens to pass the usernames and credentials over as well. So in this case, this is a QR one. This was done with this paper was printed out, and this is part of kind of a physical engagement. It was posted up in an employee room, and we actually got valid, people QRing them and setting up valid emails and passwords for their Microsoft accounts. And these work with, this is one way you can bypass MFA in certain areas, as this will provide tokens that are valid, right? So you don't need the MFA. So with those big ones out of the way, credential stuffing, phishing, let's talk about some more interesting ones, right? Sensitive information disclosure, that's a big one. There's a lot of different ways that information is disclosed nowadays. You've got info stealers, malware, you've got bad commits on GitHub, you've got just devs now more than ever have a lot of information, a lot of power. There's lots of keys, there's lots of tools, lots of devs are using those tools. So it's really important to maintain good hygiene and just kind of be aware of what is being used. And the top example here is an OpenAI key, right? Not the end of the world, but nowadays they're becoming more and more prevalent and more used. Bottom, your standard AWS keys, right? These ones are internal Git commits, right? A little bit more protected. These ones are actually external. These are external commits to GitHub. They just happen to exist there. All the blurred out pieces are passwords. And this was for, an engagement we did, and this is collecting information that's just out there, via kind of poor dev practices there and controls around security. Expanding into that, you go from your public information that just happens to exist out there to information that shouldn't necessarily exist out there, but can because of vulnerabilities. You start looking at local file inclusion and things like that. We're going to talk about that a little bit more. Configuration files when you're building applications are really the key targets for attackers in a lot of cases. I mean, it's very rare for an application to actually get remote code execution. We do have some examples. We're going to show you that. A lot of times what you get is maybe a limited execution or a local file inclusion, and that gives you a starting point to go to further, right? So in this example, this is local file inclusion. The top piece is just testing it with etc password. The bottom is kind of spending time to go find an actual environmental file that exists on the file server, and then there's your Azure keys. And at that point, you've got an entry into an actual corporate environment with these keys. You can really expand where you're going. That stems from just a simple web exploitation. So it's kind of really important nowadays to be key management and kind of moving away from this environmental page is one of the big pieces that we're seeing nowadays, whether it's being loaded in as environmental variables or as a container or kind of temporary runtime things or roles, for example, in AWS. It's much more prevalent and generally a much more secure method. These older styles of just kind of putting the keys in a file and expecting not to be identified, right? Same thing with AWS keys. The past was Azure. This one's AWS. This is an example of keys that were found on a QA endpoint where it was just the JSON file that was showing it. And QA and staging, we're going to talk about a little bit, is another big area where you have oftentimes parity in the production environment without the same controls, right? It's very often that you'll see a QA or stage environment where authentication isn't set up on the endpoints correctly, like this one. And you can see that there's actually no authentication cookies or anything like that. This is just an open JSON page, right? Obviously, it's not that common to get something like this, but it does happen. This is a real one from a engagement. Those were valid keys. Those keys were valid for AWS secrets. So using that, we were able to pull client AWS secrets and just get more additional information, right?
Hey, Julian, was that on an internal server or was that external?
This is external.
Seriously? Okay.
Yeah. It's not very common to see that level. I mean, this is this is one we just identified pretty quickly. And like, hey, you've got this external, but it does happen sometimes. Again, the biggest one is local file inclusion, right? If you get that, it is kind of the gateway for a lot of your web application attacks. It gets you access to the underlying environment. It gets you access to the underlying files and those sort of pieces. And that's from there, it makes it much easier to expand. We're going to show another example where local file inclusion actually leads to remote code execution, right? So any cases in an application where you're handling files or anything of that nature is very important, right? So, Git file or anything like that, it's critical that those are identified as kind of high value functions. We'll talk about that a little bit at the end. But if you're developing an application or you're doing threat modeling on an application, one of the key things you can do is identify these high value areas of impact in terms of functions that could go. So those are things like file loads or user modifications or administrative functionality, anything of that nature, anything that maybe manipulates the underlying server or moves data in between. And then you've got kind of the secondary ones like your input pieces and things of that nature, right? So this is a pretty straightforward example. Etsy password, pulls the internal things, right? I talked about QA, same concept with things like staging content. This was a staging endpoint that had a JavaScript file. Inside that JavaScript file is a list of different variables for client IDs and client secrets for OAuth, right? So you can see local dev, QA, staging, prod. And this was, if I remember correctly, unprotected or protected with basic user auth, right? So if somebody was basic auth to the endpoint. And that wouldn't be a huge deal on its own, but a lot of times with staging, what ends up happening is you can use that information to move into production. So you take these client IDs and these secrets and these scopes, and you curl it against the actual production OAuth endpoint, and it happens to work, right? So in this case, this is a cloud API. This is the actual production one. Doing that curl command on the previous one results in a valid bearer token for the production environment. So at this point, you've now moved into the origin of staging. You moved from staging to production with valid credentials. And that's pretty common. You see, especially the authentication pieces. That's one area where you can get crossover. Things like OAuth are a really common example of that. So it can be, an important piece to try to separate those out as much as possible, which can be difficult. So those were a little bit more on the web app side. We're going to talk a little bit now about kind of just red team in general, and these relate to web app and to application security. But they're also just kind of a little bit more on infrastructure management, things like that. Pretty rare to see, but one of the ones that we enjoy a little bit is the subdomain takeovers. As a lot of applications start to be more cloud-based, this becomes a bigger issue. One of the most common sort of ways this happens is you get CNAME records that were pointed at one time at a cloud application or something of that nature. And over time, that application was removed or deleted or something like that, but the CNAME was never cleared up. So at this point, this top piece you can see here, this is a providers.blank. And this actually points back to this cloud app azure.com, right? So that DNS name exists and it's tied to an actual company, but the underlying cloud app no longer exists. They deleted it. What you can do is you can go to Azure and you can register your own cloud app and you can give it a custom DNS name, right? As long as you do it in the same region and everything like that. And at that point, you now own the underlying website. You can, redirect people here. It looks like a valid website and you can put whatever you want. Providers like Pantheon, for example, and a couple other ones do the same thing. You can, they have a DNS name set up, but they don't have an underlying piece. You can sign up for an account, you can buy a WordPress domain, set the custom domain, and then all of a sudden you own that website, right? So it's fairly rare to see this, but it does happen occasionally. And it's one of those situations a lot of times where it's different people owning different aspects. A lot of times the web application people might not own DNS. It might be more of a security thing or a company thing, and you can get kind of friction or miscommunication between the teams in terms of what's still active and what exists there. I'm going to talk a little bit at the end about asset management and its importance there. It kind of feeds into the same concept. So this is more for like big organizations that maybe have lots of different pieces of that. Right? I talked earlier about local file inclusion and kind of its impact. This is one of the ways that it can be used. We'll show some examples here. This ASP.NET remote code execution via view state is actually one that's pretty realistic and actually we've seen it on being used by attackers in the wild. We've had clients that have come to us and said, hey, we've been attacked by this. We want to verify and see, and we were able to show them, yeah, this is how, right? So there are examples of CVEs in 2025, and there are identifications from Microsoft Security about attackers that are using this, right? So this is one that I wanted to show because it's kind of interesting, right? The main crux of the attack is that there is a validation key and a description or decryption key, and those handle authentication and encryption for ASP.NET. What these ASP.NET applications do is they store the information for requests that are sent in view state. And if you are able to create an encoded view state packet, you can manipulate it to cause execution, command execution, right? So this is a whole bunch of text there. There's basically 3 steps here. The first one is, like I talked about, that local file inclusion. So if you find a endpoint on a web ASP.NET application that has local file inclusion, you can go and read the web.config. In older ones or ones that aren't set up with key storage, you can get the validation and decryption key. They're just stored on the server. This is kind of the older model. This is how they're done. There are solutions now for storing it in environmental variables, or basically just not storing it in memory or on files in the application. And that is the recommendation. If it is still stored in files and you're able to get it, there's a tool called YSO serial, and you basically can create a command. In this case, echo 123 to a temp file, give it the information, the validation keys, all that, and it'll spit out an encoded command, a serialized command. All you need to do in that case is put it into the view state, and then it will actually verify. And this is that same LFI kind of verifying that the Joe.text was exploited and created on the actual endpoint, right? So this is an attack that's still there, and it's kind of a combined attack, right? It's you've got the LFI, you've got there's multiple things that led to this. If this LFI was fixed, you couldn't do it. If these validation keys weren't there, you couldn't do it, right? Things of that nature. So it's important that all the different security controls are looked at, right? SQL injection has always been an issue. It remains an issue, not as much as it used to be. A lot of people and most developers now do prepared statements, for example, and they're much better at not being able to create or not creating SQL injection points, but it does still exist, right? So this is a parameterized SQL injection. It's just an endpoint. It has an ID, right? And by manipulating the variable in that parameter, because it's passed directly into the SQL command, you can get it to potentially return back SQL information. This is an example at I believe it's a higher education, and by finding this and kind of working through it, we were able to pull information, including usernames, passwords, IDs for people that were attending that, right? And this is existed on just a publicly available, unauthenticated page that was associated to that organization. So it's an example of lack of authentication as well as the SQL piece. And then additionally, it's really it was information that the application doesn't need to know. It was hooked into a database of real, valid, very sensitive information, and there's not really a reason why this sort of a web application needed that sort of level of access. It's a case where it may have been better if it was just able to only get a portion of it, right? This is something that it's not in this anything I've talked about today, but when you start looking at what data your application pulls, whether it's from an API or a database or anything of that nature, one of the best things you can do as kind of a defense in depth is to limit the amount of data you're actually pulling, right? If your application only needs to know the name, you make a database query, don't pull all the rest of the files, right? Or you make an API query, leave all that information out of the response. And it may be easier just to bring the whole response and then parse through it. But in that case, even if you're not using that data, it is still being pulled into the application, which means that anybody could see all that information. One of the most common things we find that's kind of low severity in a lot of cases, but is excess information in APIs specifically. It's a very common piece. So same sort of concept here. This is just another example, SQL injection. This is a post parameter, for example. A lot of times these parameters still exist. It's pretty rare. It's kind of more basic web apps, things of that nature. What we see a lot more, or at least starting to see more of, is SQL injection in data parameters or headers, right? Areas where it might not have been expected, but the application is set in such a way that it takes that data from those headers and it's processing it, right? It's like you can see here, it's page names, case license category. So at some point, it's processing this header data and attempting to execute SQL with it, right? It's trying to pull up a category name or table name or something of that nature. And this is a case where we see it more often because developers may not kind of recognize or realize that the headers or where they're pulling the information from is not secure, right? It can be manipulated. And when it's a direct parameter, most developers nowadays are aware of that. They know, like, hey, if I'm doing this SQL parameter, I need a parameterized setup, or I need to be aware that can be injected. But a lot of times they're thinking, oh, let me just pull this header information, which in their mind is static, right? The headers shouldn't be changed, or the application sets the headers. And that's not true, right? Almost any information on the requests can be modified. A lot of times it may not work depending on what you modify, but for things like headers, those are just data storage. They're not secure. So that was a pretty kind of wide-ranging overview of a couple of different pieces and things like that. In terms of why these issues persist and what to do about them, I mean, there's infinite ways to kind of look at it. One of the biggest ones here is when you talk about the corporate level and for larger companies is asset inventory. It's one of the biggest things we see is that you may have differing teams that are handling creating applications or maintaining. The security team might be involved in getting the IPs or the DNS, where there might be a cloud team that's handling spinning up the servers in the back end. There may be an application team that's handling actually creating the application team. There may be a separate CI/CD team that's handling, a DevOps team, right? And that can create situations like the subdomain one, for example, where you have one team removing something and the other team not updating it, things of that nature. So there can definitely be friction and issues, and that's one of the common things we see. That a lot of times leads to this lack of asset inventory. Security teams might not even know that they have applications. There's been lots of engagements that we've done where they may give us a domain or maybe a range of IPs, and we'll come back to them. We'll say, hey, you've got this dev application that looks like it's running internally, but it's open on a port, right? It's showing there. So that's a really common piece. The other piece there is kind of lack of prioritization. And I talked about it a little bit at the beginning is threat modeling, asset review. If you're building an application, understanding the critical functions of it is important for security. Really, with anything with security, time is your biggest issue, right? How much time are you going to put into securing it? You got to ensure that an application, especially if it's for an enterprise or company, it's to serve a purpose, right? You're building something typically to gain revenue or support clients or something of that nature. And that means you can't be looking at it from a security perspective forever. You have to kind of time box amount. So understanding what is the critical functions, that's going to be your authentication. It's going to be your file manipulation. It's going to be your user manipulation. Really, typically your sensitive areas are going to be anything that manipulates data in the application, right? Most of the functions that are client side are less important, typically speaking, right? So anything on the server side that's manipulating data, whether that's in the back end or the actual application function, those are critical areas to look at. You can do things like offload it, especially with things like authentication. If you're doing OAuth or stuff like that, you can offload some of that risk over there. But it's important to still be aware of that. And then I already talked about it a little bit before, QA staging. If you're going to do those sort of environments where you have separated ones, you have to ensure that there's parity and functionality, but also in security controls. If you're going to have a QA environment that operates like production, security controls in the same vein as production are important. And then some specific controls. These are really application focused. Obviously, there's lots of other controls for some of the other things I talked about. MFA, that's a big one. MFA on all applications. If it is employee based, you want to ensure that it's required for employees. And then if it's client or consumer facing, The recommendation is typically to give the option. And a lot more clients nowadays are aware of the need for MFA on most of their applications, even simple ones. I mean, um, even something like, just the like a food application or something like that. A lot of them nowadays have MFA. It's kind of required, or it's a part of functionality. So it's something that's highly recommended, right? Besides from that, you can start doing more controls on your side, server controls, rate limiting, IP, login anomalies, things like that. Secrets and credentials. That's a big one nowadays. There are more than ever, more keys. There's more tools, more third-party connections. There's open API keys. There's all these sorts of keys. Lots of applications nowadays reach out to lots of other ones. So having a way to store those securely and ensure that they're just being loaded at runtime or things of that nature, or if you have to put them in a file, ensuring the file is very secure. It can't be read very easily. Maybe it's encrypted, right? If you could do an AES encryption on the underlying file, that's one way, things like that. On the development cycle, a lot of these things are things to consider in development, but ensuring strong documentation, high value again, APIs, important endpoints, looking at those and ensuring that they have the documentation to support threat modeling later and kind of support security controls later on, right?
Hey, Julian, on MFA,
Yeah.
in consumer apps, I have a particular customer who has a consumer app, and I'm trying to convince them on MFA. I guess from a security perspective, why wouldn't we require it for all apps that we develop?
It becomes a question of who the consumers of the app are. My recommendation, of course, would be yes, it should be required on all of them. But if your consumer is just a normal person, a standard everyday, let's take for example, I used to work at Taco Bell and the Taco Bell web application. Uh, if you're requiring it, it is a significant hurdle for the pipeline from a sales perspective for a lot of people.
Yeah.
There is a consideration to be aware of the business impact of slowing people down, right? And one of the biggest things you can do is considered like the funnel, the sales funnel, right? Of if somebody goes to the website, how many steps does it take them to do whatever the function of the application is? That's one of the big considerations when implementing these security controls is if you make it required, you are consciously adding in another step there, right? Now, that can be warranted if the application has sensitive information, things of that nature. A lot of times it makes sense to give the option for the application, right? I firmly believe every application with an authentication method should have the option for MFA. You want to make sure you give the clients that. Besides from that, it becomes a business question a lot of times, right? How much do you want to put in front of clients before they get to what the endpoint is?
Yeah. Okay. Thanks.
These are just some tools. Run Zero is a great tool. We really like it for asset discovery. That's kind of identifying what's in your network and what's there. Subfinder is a good one for subdomains, DNS, stuff like that. Authentication and secrets. There are a couple, Trufflehog and GitLeaks, I believe, are both open source. So I think Subfinder and Mass, Trufflehog, and GitLeaks are all open source. The other ones are not as much. So Flare.io and SpyCloud are really good at a enterprise level. They are great solutions for identifying breach credentials and kind of identifying stuff in the dark web, things like that. The CI/CD is not exactly my area. I did some kind of research on that. These are all solutions I found that seemed pretty good for kind of implementing at the shift left level and the development level, right? And really, that is it. I know there's kind of a hodgepodge of different things, but going through some examples and then kind of helping explain what we're seeing as the testers have been doing this for a couple of years. These are the real world things we're seeing. So at this point, I'd love to open it up if there's any questions or anything like that.
Yeah, I have a question. How do you find like if company is using GitHub for your pen testing? Is it like do you have to do the recon first, or is there's like kind of like a short list that you go through to like look for all of these weaknesses?
Yeah, so the main way we do that is Google dorking is what it's called. And it used to work a little better, it still does. By submitting queries to Google with specific keywords and functionality. So like one of the keywords I believe is like site, and then parentheses. You can tell Google to only pull results from this site, for example. So we've got a whole slew of lists of these Google dorks, and one of the big ones is GitHub, right? So you tell Google, hey, only give me results from github.com that have this organization keyword in there, and that's one of the common ways to find stuff like that. Well, I will end it there. Megan has my contact information, and I'm always happy to answer questions from people in the security field. So if anything pops in your guys' mind, please feel free to reach out. Happy to chat through.
Yeah, and if nobody has any specific questions, I can stop the recording and we can ask without too. So some people like to do that. I know. Cool. But yeah, thank you very much, Julian. That was a really good talk.
Yeah, it was kind of fun to actually go through some of the look through our tests. I don't get a chance to look through all of the old ones and find some interesting ones to share. I mean, one of the things I didn't include in here is I couldn't find the example of it. There was a test that I did 4 years ago or so where the company had their Duo MFA for new employees set up so that anybody that logged into it could set up MFA, right? And we found breach credentials for a new employee and went to log in and it said, hey, would you like to set up MFA? And we're like, yeah, sure, we would love to. So we went and set up MFA and then we've got access to the account, right? So there's interesting stuff like that.